Good morning, good afternoon, good evening, depending on where you are. Welcome to today's session called LLM Solutions and How to Use Them. A big one, an exciting one. We have more than 600 registrations, which is pretty insane. It's undoubtedly the first time that I'll be going solo in front of such a big audience. So no pressure though. I will start by quickly introducing myself. I guess that a lot of people do not know me. My name is Jourik. Ciesielski. I will be your host today. The truth of the matter is that I'm wearing a lot of hats in the localization industry. I'm the CTO for an amazing LSP based in Belgium. I run my own company, and I'm also involved with NIMS Insights, where I work on a lot of interesting stuff as a senior consultant and researcher. On a higher level, I provide three big services: technology consulting, localization engineering, and industry research, market research. My main fields of expertise are audio-visual translation. I am very interested in speech, speech-to-speech, text-to-speech, speech-to-text, whatever direction you are working on. Machine translation is one of my fields of expertise, and also Gen AI and large language models, which is basically why I am your host today, why I'm talking you through today's content. And last but not least, I also like to work a lot on the TMS market. Very interesting market, and very interesting stuff is happening in that market, also in the field of generative AI and large language models. Today, you are in the very first session of NIMS Insights' very first Gen AI event series. So we've designed a series of events centered around generative AI and large language models in the language services industry. And the main focus will be on applications, implementations, and use cases. So we don't want to talk too much anymore about disruption and impact. We all know what's happening. We all know the hype. We all know the trend. We really want to focus on you're a company, you're a business, and you want to get your hands dirty and you want to do stuff with this new technology. That's what we want to talk about. We've designed the series in such a way that every session is supposed to be rich enough in terms of content to be seen as a standalone event. However, there will be some interconnection between the different sessions. So the next session, I won't reveal yet what it will be about, but the next session will be an iteration of this session. So we want to provide you, our audience, our participants, a top experience by offering a full series rather than one standalone event. And then we can move on. The event is for you. So you're interested in Gen AI and LLMs, right? You've had a taste of ChatGPT, you've played around with the technology, and you're fascinated, you're intrigued, and you want to know more about this technology. We will help you out. You're curious about potential use cases, you have some ideas, you want to validate them, you're not sure where to start, you're not sure whether you're doing the right thing. We aim to help you through this session. You want to embark on developing your own application, so you've got your hands dirty already, you've tried some things, it's working out, but you can improve it, it's not working out well yet. Whatever, we're here to help you. Or a more general more general objective, you want to know what's happening on the technology market, you want to know what's moving, and we are here to talk about what's happening on the technology market as well. And then I think we can continue with today's agenda. Our agenda is packed. We have so much things to talk about and so little time. We have different sections, and for every section there will be like one key thought, key idea, key takeaway. We will start with a very, well, not a very big, but with a quite large introduction, where the aim is to define AI. The key idea is, if you're serious about doing business with this technology, you need to understand this technology well. You need to be able to convey the correct message towards your clients, your buyers, your stakeholders. So we will define AI. We will talk about some very crucial concepts like deep learning, attention, self-attention, transformer models. about foundation models and something I like a lot myself, which is retrieval augmented generation. Very powerful, but pretty unknown. So I want to dedicate at least one slide to retrieval augmented generation. Then we will move on to the next section, the next topic, use cases. And here, the key idea, the key takeaway is that every idea is a potential use case, a very notorious one-liner. But to contrast with the other primary important form of linguistic AI, machine translation can't be any bigger, right? When dealing with LLMs, every idea is a potential use case. And that's what I want to prove through a couple of slides. We will break down one specific use case, which is using LLMs for machine translation. We'll talk about more use cases, and there's one specific use case which seems to have broken through already, multilingual copywriting. I will try to prove with a couple of arguments why that is. Then we will move on with the next topic, embarking on the Gen AI journey. And the key insight here is, engineers, it's time to shine. It's time to step up. You hold the key. You can do very important things. You can generate some real impact. It's up to you. It's time to step up. If you are an engineer and you don't know where to start, I will try to provide a couple of guidelines that might help you. And then the last part of the presentation is about the technology market. And again, here I have two key insights. The first key insight is that if you've ever done something in AWS, for example, Amazon, Google Cloud, or Microsoft Azure, then LLM catalogs are closer than you think. That's key insight number one. Key insight number two is there has been a lot of movement. There has been a lot of activity in the technology market, mainly in the TMS market. So far, I dare to say that the impact is relatively low, but we anticipate that 2024 is going to be the year of real impact in the language technology market with LLMs and with generative AI. That being said, I think we're all set to rock and roll, and we can get started with the first section, which is defining AI. A big definition on this slide, and while I give you some time to read this definition, I'm not going to read it out loud, but I'm just going to drop a very controversial opinion right away into the room, right? And my controversial opinion is that AI is cool. It's a very nice toy. It can do very impressive things. But unless you manage to enhance your productivity by deploying AI, it is pretty useless. That's a controversial opinion. I heard it yesterday. I liked it, and I wanted to drop it in the room today as well. I'm not going to work on this large definition on this slide, but I do want to work on another definition, which we have on the next slide. This is a definition provided by IBM. Artificial intelligence, or AI, is technology that enables computers and machines to simulate human intelligence and problem-solving capabilities. And what I take away from this definition is simulate human intelligence, right? It's not human intelligence. It's basically a matter of mimicking human intelligence. It's not magic. It's not abracadabra. There is a logic underneath it. There is an algorithm underneath it. And this algorithm can be a very simple rule-based algorithm. Like, for example, a very simple search and replace operation, optionally driven by regular expressions. According to our definition, that is a form of AI, right? Rule-based machine translation, is that a form of AI? It definitely is a form of AI. So people, ChatGPT does not equal AI. AI entails a lot more than what you've done, than what you've seen in ChatGPT. Nevertheless, what we are really interested in is, of course, the neural network technology. And I do have a slide where I will try to explain how neural networks work. It's not an easy thing to do, but I will try to keep it very, very simple. So this is a representation. This is a visual representation of a neural network, and I will try to explain how it works. A neural network typically consists of two parts, an encoder on the one hand and a decoder on the other hand. The encoder takes the input, which can be a text string, which can be something else, but let's say text string. And the encoder will convert every individual word in the input into a number. 001, 101, 100, etc., and so on. We call these numbers, these mathematical representations, vectors or embeddings, right? Between the encoder and the decoder, you have all these dots, right? All the dots that you see on the image. These dots are called layers. And layers are intended to analyze the relationship between the different vectors, between the different embeddings in a sequence. This implies two very important things. The analysis of the relationship between the vectors, between the embeddings, happens based on the training data. So number one, the quality and the amount of your training data is so very important, which I guess you already know. Number two, very important implication, the amount of layers between the encoder and the decoder determines whether you're dealing with a deep learning neural network or not, right? A neural machine translation model contains hundreds of layers between the encoder and the decoder. So is neural machine translation a form of deep learning neural network, deep learning neural AI? The answer is a big fat yes. And then we have the decoder. The decoder will take the embeddings, will take the vectors, and will try to produce an output for it by continuously predicting the next best word in the output. Remember this, continuously predicting next best word in the output, because this is exactly what Gen AI is. This is what Gen AI means. This is what it does, continuously predicting the next best word in the output. Very important key takeaway that you should take away from today's session. Okay, and then I think we can move on to the next one. There's something more, right? There is something more about neural network technology that you need to be aware of. It's the concept of attention, right? You might have heard of this, but again, I will try to explain it as simply as possible. Attention is an extra layer on top of your neural network, on top of your neural model. And attention basically allows the model to look at different elements in the input with different levels of importance. So it will process different elements in the input differently with different levels of attention. Attention is what a neural network allows to take, for example, a sentence like the animal didn't cross the street because it was too tired. It will know that in this sentence, it refers to the animal. Whereas in the sentence, the animal didn't cross the street because it was too wide, the model will know, because of attention, that the word it refers to the street in this case and not to the word animal. Now, if you are into data science, if you are into neural networks, you will know that the title of this slide, Attention is All You Need, actually refers to a very important research paper published by Google in 2017. Attention is all you need. Why is this paper so important? Because of a number of reasons. First of all, in this paper, Google kind of repurposed the concept of attention as self-attention, and I will explain on the next slide what self-attention is and what it does. So that's number one, repurposing attention to self-attention. Number two, it introduced a brand new model architecture based on the concept of self-attention, the transformer, which I guess you've all heard of. And number three, Google designed the transformer model initially for machine translation tasks, right? So the language services industry was a very important industry in the breakthrough of neural networks, in the breakthrough of transformer models, and therefore also in the breakthrough of large language models. And then we can move on to the next slide and have a couple of bullets about transformers, right? So we went over the fact that transformers were introduced by Google in 2017. What does self-attention mean? That's basically what I want to explain on this slide. Self-attention means that the model will take the input and it will dynamically generate embeddings, so numbers. It will dynamically generate embeddings for each and every individual word in the input. At the same time, it will dynamically compute attention scores for every individual word in the input with respect to every other word in the input, regardless of their position, right? And then it will generate new embeddings for every individual word in the input, taking into account the entire context based on the intention scores. And it will generate new embeddings 2 times, 3 times, 4 times, 5 times, numerous times until it reaches the final representations of embeddings, right? So this is quick, this is fast, this is very, very powerful. What are the advantages of self-attention compared to the more traditional concept of attention? Number one, high accuracy, right? A model, transformer model based on self-attention can capture long-range dependencies and relationships between words in the input sequence. So imagine you have an input sequence that contains 1,000 words. Because of the concept of self-attention, the model will be able to understand the finest relationship between the very first word and the very last word in the input. That's advantage number one. Advantage number two, computational performance. The model will be able to digest more training data, a lot more training data at a very fast pace. As I mentioned, the transformer was originally intended for machine translation tasks, but Google and other companies find out that transformers were equally capable of just understanding language in one language and generating an output for the input in the same language. And that way, it ended up being the foundation of what we have today in, for example, GPT, aka the large language model. So that's the story behind it. Neural networks, transformers, self-attention, and today we are in a new reality, the reality of large language models. Very quick sip of water. And then we can move on to our next slide. So in this slide, I quickly want to explain how a large language model is actually built, trained, constructed, right? First of all, very important to know, a large language model is not exclusively trained on text data. It is trained on multi-model data, which can be text, that's perfectly fine. It can be all kinds of structured data. It can be images, it can be audio, it can be video, it can be a lot of interesting training data. The data is leveraged to run a pre-training, and this pre-training is unsupervised. What does that mean? The model is trained, but without the purpose of training it into a task-specific model. It needs to be general purpose. The model, the result, is not supposed to execute one task specifically. It's supposed to be able to take on numerous tasks, right? So multi-model training data and unsupervised training data, or unsupervised training, meaning the model is not supposed to execute one specific task after its initial training, after its pre-training. After the pre-training, the model gets decoupled from its training data, and at that point, we talk about a foundation model, which is, for example, GPT 3.5 Turbo, which is, for example, GPT-4. That's the model that you're using. That's the model that you are leveraging when you do stuff in ChatGPT. There you are working with a foundation model. Of course, you can take a foundation model and you can further train it, fine-tune it, adapt it into an adapted model, a task-specific model, right? The adaptation can happen through further training, so real fine-tuning on training data, but also through tailored prompting, of course. What are the typical tasks for a large language model? Translation, the most important one for our industry, the language services industry. Text generation, so copywriting, structured writing, whatever. Question answering, think about customer support, think about chatbots. Sentiment analysis, text classification, text summarization, the more typical NLP tasks. And of course, object recognition. Again, large language models are not intended to work exclusively with language, with text. They can also work with images. They can also work with speech. They can work with many different types of data. Object recognition, image recognition, image generation, think about DALL-E is something else that a fine-tuned, adapted large language model can do for you. And then we can move on to the next one. ChatGPT is what kind of caused the hype, right? So OpenAI was very clever when they released ChatGPT because they gave the whole wide world the option to play around with a large language model. A large language model was not necessarily new in November 2022 when ChatGPT was released, had been around for years already. OpenAI was the first one to provide easy access to the whole wide world to large language models. GPT stands for Generative Pre-trained Transformer, and based on the things that we have been discussing so far, we now know what that means. We now know what that stands for. Generative stands for generative AI, the ability to continuously predict the next best word in the output. Here we are again. Pre-trained means trained, but not with the intention, not with the purpose of having a task-specific model, trained with the intention to have a general purpose model that can take on multiple tasks. And then the transformer refers to the model architecture as announced, as introduced, as released by Google in its very notorious paper, Attention is All You Need, in 2017. And then we can move on. As anticipated, as mentioned, I want to dedicate one slide, and only one slide, I promise, to a concept that I'm crazy about. It's retrieval augmented generation. What is retrieval augmented generation? Retrieval augmented generation, or RAG, basically means that you will use a second model, a second neural network, and the second neural network will be used exclusively for data ingestion, for data parsing, right? So that model can take on data from whatever channel. It can be offline documents, static documents, PDFs, web pages, APIs, cloud buckets, whatever. It can take the data from all kinds of input channels, and it will turn that data into embeddings. And we now know what an embedding is. It's a number, right? Your large language model, your GPT or your Gemini or whatever, will then be used exclusively for content generation and Q&A. It will look exclusively at the data parsed by your second model as the only source of truth, right? What are the advantages of working with a RAG-based mechanism? What are the advantages of working with a separate model for data parsing, for data ingestion? Number one, higher factual accuracy. IBM refers to working with RAG as the open book versus closed book exam principle. If you don't use RAG, you're working with the closed book principle, meaning that if you ask the model a question it doesn't know, it will try to come up with some kind of answer. Whereas with an open book example, the model can actually look at the content, look at existing data, retrieve the appropriate pieces of data, and generate a highly accurate answer for you. Number two, I don't know. If you ask the model a question that it doesn't know, it will say, sorry, I don't know. So it will reduce the chance of hallucinations. Even stronger, if you ask it or if you try to trick it into a wrong answer, which is very easy to do, in, for example, ChatGPT, the model will say, sorry, you are wrong. This is what's going on, right? That's quite revolutionary, at least if you're used to working with ChatGPT. Number three, multilingual. Data, reference data, legacy data parsed by the second model in English can be used to generate content in other languages and vice versa. So you can perfectly upload a document in Romanian and ask the model to do something in Turkish. That's perfectly possible. Deployments, for which cases, for which scenarios is RAG interesting? Mainly question answering systems, so company-specific chatbots, product-specific question answering mechanisms. That's the main use case. But you can, of course, fine-tune a RAG-driven application into a more task-specific application than just Q&A. And then the last point that I want to mention on this slide is if you work with a RAG framework, a RAG mechanism like Llama Index or LangChain, there are also advanced prompting techniques such as condensed questions that you can use in your code, prompting templates, and more interesting stuff. Retrieval augmented generation, RAG, remember the name because this is very powerful. This is very interesting. And that's what I wanted to say, I think, in our introduction. And then I think we are all set to move on to the next part of today's presentation, which is use cases. And here I am again with my very notorious one-liner. Every idea is a potential use case. I will emphasize a lot that the contrast with machine translation can't be any bigger because machine translation comes with only one use case, which is translation from one language into another. And that doesn't really apply to LLMs because the use cases offer for you are much more than just translation from one language into another language. Now, before I start talking about real use cases, I quickly want to emphasize, and I guess you all know this, but I still want to emphasize why large language models are so powerful and why large language models are like a new default in the whole field of AI, right? So we can bring up the next slide. There are two things that large language models can do. First of all, they have the ability to learn from context. You can give a large language model a source text and the model can read it and memorize it. You can do the same thing with legacy translations. You can do the same thing with style guides. You can do the same thing with glossaries. You can give it any kind of additional input and the model will try to learn from the input that you have provided. More intriguingly, LLMs are capable of respecting human instructions. If you tell the model to do something, it will do it. Not always perfectly, but it will try to do it. If you want an output of exactly 50 words, it will try to give you exactly 50 words. If you want the model to translate something in the style of children or in the style of C-suite executives, it will try to do it. You can give it instructions and the model will try to respect and follow those instructions, right? And I have an example, right? And if you've ever been in one of my presentations, you will know that I always give this example. It's actually pretty stupid, but it's pretty representative, right? So my prompt is write a sonnet about machine translation in Snoop Dogg style, right? This is what I insert in ChatGPT, and 0.2 seconds later, I get this. Yo, get around, I got a tale to spin about machines that turn languages to kin. Translation game, it's all the new wave. Snoop Dogg style, let me drop it, behave. From English to Spanish, French to Chinese, those AI translators aim to please. They break down barriers, walls they erase, bringing the world together, tight embrace. Linguistic acrobatics they display, switching tongues like it's just another day. Slang and jargon ain't no trouble for these. Snoop Dogg vibes breezing through with ease. Machine translations shaking up the scene, uniting cultures, living the dream. You know what I mean. Now, I'm not an expert in poetry, but I do know that this is a technically perfect sonnet. Is it about machine translation? It definitely is about machine translation. Is it in Snoop Dogg style? I think you can argue about that, but I would not have done it better myself. So we have 3 instructions, sonnet, machine translation, Snoop Dogg style, and 0.2 seconds later, I get an almost perfect output. And that is the true power of large language models, right? So if we take that and we apply it to a real use case, we can, for example, say, use a large language model for machine translation. How does that work? If you want to ask the model, if you want the model to produce a translation for you, you basically have to build a conversation with the model. So this is something that you would do in your code, right, under the hood. You have to build a conversation with the model and you have to use 3 different roles. In the case of OpenAI models, it's system, assistant, and user. The system is supposed to set the stage, is supposed to warm up the model, and is supposed to tell the model the position, the persona it is supposed to take. For example, you are an English into French medical translator who is capable of respecting instructions from style guides and following glossaries. Then the assistant kicks in, right? And the assistant is supposed to provide the model with all kinds of reference data or even examples, right? If you have a desired answer, a desired output, you can give it as an example in the assistant role. But in our case, in our use case, LLMs for machine translation, we can, for example, say, here is a style guide, and there are instructions in the style guide, and I want you to follow the instructions as defined in this style guide. For example, avoid the use of masculine pronouns, right? If we want to generate gender-inclusive translations, we can, for example, say, you need to avoid the use of masculine pronouns at all costs. The assistant can come in again and can leverage a terminology list. Dear model, I want you to use the following glossary when translating, and then you provide it with all the terms, source, target, and ask the model to respect the terms when producing a translation. And then the user kicks in, and the user is supposed to ask the model to do something. So in this case, the user asks the model to produce a translation. Hey, model, I want you to produce a translation for me for this source text, taking into account the translator persona, taking into account the instructions from the style guide, taking into account the terminology leveraged in this glossary, and I only want you to give me a translation. No introduction messages, no explanations why. I just want you to give me the translation. Boom. And it will give you the perfect gender inclusive translation. Well, maybe not perfect, but it will give you a gender inclusive translation. That's how it works. That's how you can deploy a large language model for machine translation purposes. Now, once you understand this logic, once you get this to work, doors towards other interesting use cases will open very quickly, right? Because if you can ask the model to produce a translation, you can also ask the model to edit an existing translation, automated post-editing. You can also ask the model to evaluate the quality of an existing translation, AI-driven LQA. You can also ask the model to identify keywords or term candidates in the translations, automated terminology extraction, etc., and so on, right? So this is how it works. And once you get this to work, you will be able to create more use cases yourself. That's the point I want to convey here. And of course, there are more use cases, and I have another slide with a couple of examples. Use cases are the typical NLP tasks, the typical content operations, such as content creation, multilingual content writing, that's perfectly possible, rewriting of content, summarizing content, detecting biased and harmful content, etc., and so on. Different types of QA, which I kind of mentioned already. You can even use it to perform machine translation quality estimation, for example. Terminology extraction is something else I already mentioned. Even multilingual terminology extraction, that's perfectly possible. Engineering, imagine you're working with a software and for some reason it goes wrong, an error message. The model can actually help you to troubleshoot the error, or write a little script for you, or write a little automation for you, right? It's actually your coding, your best friend in terms of coding. It's actually the best assistant ever, right? Another use case, linguistic context, right? If you are a translator, if you are a project manager and you're working on a project and you need some more context for a given source sentence, what do you typically do? You go to Google, you insert your search query, you scan the first couple of results, and hopefully you find the answer that you're looking for. Now you can just ask the question to your model, and the model will give you a hint. Maybe it will not give you the answer right away, but it will be faster, and there's a higher chance of having the requested context at a faster pace. Something else that people tend to forget often because we're so focused on translation, but we can also use large language models for related disciplines. So disciplines related to translation. Think about technical writing, for example, converting unstructured data into structured data. Think about text-to-speech, preparing plain text for text-to-speech by converting it into SSML, for example, etc., and so on. Here I am again. Every idea is a potential use case. So those are the use cases. Then we can move on to the next slide. As I mentioned in the agenda, in the introduction, there is one use case that seems to have broken through already. It's multilingual content creation, and I'm not making this up, right? I have a couple of arguments that I want to use to prove that multilingual content creation is a thing. I actually have one big argument, and that argument is that pure translation technology providers are actually embarking on releasing copywriting apps and creative assistant apps for writing, right? For content writing. DeepL, for example, machine translation technology, but they have an AI assistant. Lilt released something that's called Lilt Create, which you can use to generate multilingual content. Exact same thing applies to SmartCat, a translation management system provider. And then the best example is undoubtedly Writer, which is the last logo on the slide. Writer used to be a translation management system called Cordoba. They recently collected a big bag of money, $100 million to be precise, to repurpose themselves as a multilingual content creation app. So multilingual content creation breaking through, that is happening. That's where business is happening. That's where money is going on. So multilingual content creation, check. And then I think we are at the end of the use cases section. We can move on to the next one. We can bring up our slides again. And we can talk about embarking on the generative AI journey. So again, you are a company, you are an organization, you've had a taste of ChatGPT, and now you want to do something with this technology, right? You want to leverage this technology to make your life easier or potentially create new services or products around it. How do you get started? My key message here, my key piece of advice is, engineers, localization engineers, it's time for you to step up. It's time for you to shine. We are in the middle of a period where, on the one hand, you can have a lot of fun, but on the other hand, you can also make a real difference, right? And of course, I have a couple of arguments that I would like to use to prove that localization engineering is now more important than ever, and that there is a big difference with machine translation where those skills are not so crucial, right? So we can bring up the slide and talk about those arguments and talk about those reasons. That's not the correct slide. We should go back a little bit. There we are. The need for localization engineering skills. Why is it so important to have localization engineering skills, preferably in-house? First of all, I already mentioned it, the contrast with machine translation can't be any bigger, right? Machine translation is so extremely task specific. There's only one use case. You have a piece of data, you send it to a model, and you want to have that piece of data returned in another language, right? We can actually rely on the tech companies, on our technology partners to build those use cases and to build those integrations for us, because it can't go wrong. Well, it can go wrong, but normally if everything goes well, it should work like a charm. On top of that, machine translation is already everywhere, right? In your favorite CMS, you will have machine translation plugins. TMS is very equipped with machine translation plugins. Large learning management systems, internet browsers, machine translation is everywhere. Machine translation became a commodity, and we're not quite there yet with LLMs. So that's reason number one, right? We're used to machine translation, but this is something else. Number two, certain tech companies were a little bit caught by surprise by the advent of Gen AI. So imagine you are working with a technology company, you have a big contract with a certain company, and for some reason that company, your partner, fails to follow the trend, fails to adapt to the hype, and fails to release LLM-driven features for you, right? If your technology partner doesn't follow the trend, then you might get behind the curve as well, right? So if you have the technology, not the technology, if you have the experience, if you have the skills, if you have the expertise to do something yourself, you can avoid that scenario, right? Again, need for localization engineering skills. And then we can bring up the slide again. Number 3, large language models offer a much broader range of potential use cases than machine translation ever could. We determined this, and this might be too much weight to carry for the technology companies. This sounds negative, but it's not. We cannot expect the technology companies, for example, the TMS providers, to provide support for every possible idea of every possible customer. That's just not going to happen, right? If you work with technology and you have a feature request, you know how difficult it is and you know how long it might take for your feature request to be implemented. And that's not going to change with large language models. And then the last argument, most large language models are mainly API first or even API only solutions, right? So they don't come with fancy dashboards. They don't come with consoles. They don't come with whatever, right? They are API first solutions, which means that if you want to make use of a large language model and you want to build your own use case on top of a large language model, you need to be able to operate the API, hence the higher need for localization engineering skills or engineering skills in general. That being said, we can provide a couple of guidelines. So you're a company, you do have some engineering skills in-house. What's important? First of all, know your standards, right? You need to know your way around JSON. You need to know your way around APIs. You need to be able to read the documentation of the APIs. And especially XML is important. You might know this, but in language technology, basically every standard is based on XML. So imagine you have this crazy idea, well, not crazy idea, good idea, where you want to get an XLIF out of your favorite TMS. And for every translation unit, you want to send the source and the target to the large language model, ask it to do something, provide the quality estimation score, whatever, retrieve the results and write them back in a comment or in a note for every translation unit. That is a great idea. As a matter of fact, I'm doing that myself already. But you need to know your way around XML. You need to understand XML. You need to understand XLIF. And once you do that, the step towards using a large language model, adding a large language model on top of it is a lot smaller, right? So know your standards. It's a higher level guideline, but it's a very important guideline. Number 2, elevate those prompting skills. I used to say, like early 2023, that prompting was an overrated discipline. I wasn't exactly convinced. I had to change my mind, right? Because every dot and every comma in your prompt is important. And if you manage to apply advanced prompting techniques like few-shot prompting, one-shot prompting, chain of thought prompting, etc., you will be able to get better results out of your large language model. I guess we will talk more about prompting in the next sessions of the series. Guideline number 3, again, a high-level guideline, but a very important one. Don't try to run before you know how to walk. Work in small iterations, well-defined iterations, and build things up, right? It's easier to scale up than to scale down. So don't try to run before you know how to walk. And a similar guideline, focus on the logic rather than the product. Why? Because logics can easily be extended, enhanced, or adapted. Logics can also be launched from a simple Python script, and there's nothing wrong with that. Logics can also be launched from the command line, for example, which is a lot more complicated to do if you have a bulky product already and you want to adapt it, you want to change it, you want to enhance it. That is a lot more difficult to do. So focus on the logic rather than the product. Those were the guidelines. Then we can move on to the next part of our presentation. The technology market, right? Very interesting space. A lot is happening. And I'm going to apologize already because we're not going to spend too much time on this. This is going to be an introduction, but I do want to say a couple of things about the technology market. And the first thing I want to say, circling back to my key insight, LLM catalogs are closer than you think, right? Why? Because the technology giants are in this space. Amazon, Google, Microsoft, they are in this space, and they have a lot of interesting things to offer. right? If you've ever done something on AWS, hosting a website or whatever, you will know, or you will not know, but now you know, that Amazon also has its own LLM model studio, which is called Amazon Bedrock, right? Amazon Bedrock contains a bunch of interesting foundation models. There's Amazon Titan, Amazon's proprietary LLM range. There's Command by Cohere. There's Claude by Anthropic. A very popular LLM range, by the way, the Claude models. And there's also Llama 2 by Meta. You will know that the Llama 2 models are open sourced and they are fully hosted on Amazon Bedrock, right? So that's Amazon Bedrock, an interesting collection, an interesting catalog of foundation models. You now know what a foundation model is, and it also comes with dedicated APIs and dedicated SDKs for different programming languages. So that's Amazon Bedrock. If you've ever played with AWS, have a look at Amazon Bedrock. Google Cloud, the next tech giant, a pretty similar situation, but I think Google has more to offer when it comes to quantity, right? Not necessarily quality, but definitely when it comes to quantity. What do we have in Google Vertex AI, Google's model studio? We have, of course, the Gemini Pro models, right? Gemini is Google's answer to OpenAI's GPT models. There's full access to Gemini. There's access to the Claude models by Anthropic, Llama 2 again by Meta. And there's much more in Google Cloud. There are fine-tuned models, so task-specific models. There are models that you can train yourself on your own data. Hundreds of models. If you're working on Google Cloud, if you're on Google Workspace, please have a look because there's a lot of interesting things to do in Google Cloud, namely in Google Vertex AI. And then we also have a similar situation in Microsoft Azure, right? Azure has its own AI studio, Azure AI. And I think that Azure provides access to more than 1,600 models. So 1,600 models, which is a staggering amount of models, of course. Same situation, LLMs by different providers. Not only Microsoft, but also Hugging Face, NVIDIA. There's full access to the OpenAI model range. You will know that they have this big deal with OpenAI, this big partnership with OpenAI, Mistral, etc., and so on. There are task-specific models. There are models you can train on your own data, etc., and so on. Engineers, step up, have a look at what your cloud services provider has to offer, because I can tell you that there's a lot of nice things to work with. Engineers, have a look. Of course, we are the language services industry, and the main part of language technology, or the most dominant part of language technology, is of course our TMS, our translation management system. And the translation management system market has been very active as well since the release of ChatGPT in November 2022. I've been monitoring everything that has been released by the different TMS providers, and I've tried to categorize the different feature releases in three categories. Number one, automated translation. Number two, creative assistance. And number three, quality assurance. Automated translation, what kind of feature does that entail? Large language models for machine translation, adaptive machine translation, taking into account fuzzy matches from your translation memories, taking into account term entries from your glossaries, fuzzy match repair, a very good one as well, adaptation of content to style, formality, other style guide instructions, etc., and so on. Automated translation. Category number two, creative assistant, right? A lot of companies, a lot of technologies already have an AI assistant embedded, which is basically an integration with ChatGPT in your TMS, where you can just talk and ask questions, right? AI assistants are becoming pretty common. Creative assistants can also be used to rework content, rewrite content, shortening translations, rephrasing translations, suggesting alternative translations, and my personal favorite, SEO optimization. And then we have use case number three, or category number three, which is quality assurance. I really, really like the idea of using LLMs for QA and or LQA, because according to me, QA is one of the most obsolete disciplines in our industry. It has this traditional rule-based algorithm. It generates tons of false positives, and you need to, fight your way through all those false positives before you find a genuine mistake, and you cannot remember those false positives or migrate them from one project to another. It's a huge pain in all of our asses. And I really like the idea of using LLMs for QA purposes. What else? Content filtering, detecting biased content, detecting harmful content. That's something else that we're seeing quite often. LLMs for quality estimation, I think that might break through as well. And last but not least, another very interesting one is screenshot testing. Again, LLMs can not only work with text, they can also work with speech, they can also work with images, and screenshot testing, internationalization testing, localization testing is something else where I do see a lot of potential for LLMs. Let's have a look at a couple of names. Again, I've tried to make a categorization of the different names. This is a personal graph. This is a personal opinion, but I will explain you how I see it. First of all, I have a couple of companies in the upper left corner, RWS, GlobalLink, SmartLink, and also Lilt, and I would label their strategy when it comes to implementing LLMs as aiming for high impact. What do I mean by that? They already have automated translation features, LLM-driven translation, automated post-editing. They can work with human linguists. They can take their time to create new business models. They can experiment with new pricing models and pioneer new pricing models. So I would label their strategy as aiming for high impact. Doesn't necessarily mean that they have already achieved high impact, but they're aiming for it. That's number one. Category number two, or strategy number two, is focus on proprietary products. And I think Phrase is the most appealing name in this category. Phrase has a very strong MT offering. They have MTQE, they have MT glossaries, they have MT model routing, and they have their own MT model training studio. And they focus on optimizing their MT products offering rather than doing some kind of purposeless integration with OpenAI, for example. So they have a strong focus on their proprietary products. Category number three in the upper right corner of the graph, freely integrating, and there I've added names like Crowdin, Localize, Transifex, SmartCat, and BureauWorks. What do I mean by freely integrating? I mean that these are companies that don't have big dependencies, right? They do not have bulky legacy products. They don't have acquisitions. They can just freely experiment with large language models. They can integrate different models. They don't have to build proprietary models. They can easily work on new use cases. They can take their time. So in a way, they have a head start compared to competition, even to the ones that are aiming for high impact, according to me. And then we have category number four, task-specific implementations. The most appealing name there is MemoQ. MemoQ has released an adaptive machine translation feature built on GPT 3.5 Turbo. It takes fuzzy matches into account. It takes term entries into account. And that's MemoQ's only focus at this point when it comes to integrating LLMs. So focus on task-specific implementations. That's what I wanted to say about the TMS market. One slide about the machine translation market, so the market of the pure machine translation providers. We are seeing some interesting stuff there as well, but the overall feeling is that the MT providers are a little bit more reserved when it comes to new features, new functionalities. Makes sense because the foundational technology of their products, of their core product, is in the middle of a transition phase. Nevertheless, some interesting names, some interesting features. First of all, Modern MT, maybe one of the biggest names in the field of adaptive machine translation. They support, for example, machine translation quality estimation through their API, something that a lot of people don't know, but they have it as well. They recently released a trust attention mechanism, meaning that Modern MT will first look at the trustworthiness of the data that is used to produce a translation prior to producing a translation. And it also released a profanity filter intended to detect biased and harmful content in machine translation output. Another example, Pangeanic, they recently released their own LLM, a proprietary LLM built for the localization industry. It's basically ChatGPT in a private environment, in a safe environment, built for the localization industry by the localization industry. So that's another noteworthy initiative. And the third example is Globally. Globally is combining the power of domain-adapted neural machine translation models with the capabilities of LLMs, custom prompting, custom post-editing, automated post-editing, and whatnot. So a couple of interesting examples of things that are happening in the machine translation technology space. We're almost done. 5 minutes left. One more slide about technology companies. There are other companies, other tools, other providers. I like to call them aggregators. I think the names on this slide don't need an introduction anymore. Intento, Custom MT, Blackbird. Intento uses large language models for machine translation models by Anthropic, Azure, Google, and OpenAI. They have this fully fledged enterprise GenAI portal. You can run automated post-editing using LLMs through Intento. They have an API, and they have 10 plus TMS integrations. Similar story for Custom MT. They support translation through GPT 3.5 Turbo and GPT-4. You can upload style guides, you can upload glossaries. There's also support for Google's adaptive large language model-driven machine translation solution. They also have an API and connectors for MemoQ, SmartLink, and Trados Studio. And then Blackbird, a particular company, not exactly the same as Intento or Custom MT. They offer a variety of models. They support a variety of models, including Anthropic, including Bedrock, Vertex, Cohere, Hugging Face, Llama 2, and OpenAI, full support for OpenAI. And the thing with Blackbird is that they are a workflow orchestrator, meaning that they don't tell you when or where you need to use a large language model. You can integrate it anytime, anywhere in your workflow, right? Regardless of the workflow step, regardless of the purpose of the LLM integration. You can use it for, I call it pre-chewed use cases, call OpenAI to run automated post-editing, but you can perfectly create a custom prompt for a custom use case using the large language model of your choice in Blackbird. And then I think I need to speed up a little bit and go to, I think, the last slide of my presentation, which is the conclusion. There we go. Wrapping up everything that I've been discussing in the last hour, these are the conclusions. These are the messages that I wanted to convey through my presentation. Number one, our industry has been practicing AI for a long time already, right? We have been doing rule-based machine translation, which is a form of AI. Same thing with statistical machine translation. Same thing with neural machine translation. We need to understand that. We need to understand what AI is. We need to understand how it works. And we need to understand that we have been doing it for a long time already. That's what we need to tell our clients, our stakeholders, our buyers. Number two, every idea is a potential use case. Again, the contrast with machine translation can't be any bigger because machine translation has only one use case and machine translation is everywhere. Machine translation is a commodity. Number three, localization engineering is more important than ever. If you have a use case, if you have an idea, you might need to get your hands dirty if you want to do something with it. Number four, LLM catalogs are closer than you think. Have a look at what AWS has to offer. Have a look at what Google has to offer. Same thing for Microsoft Azure. And the last conclusion, a lot is happening in the technology space already. The TMS market has been very active. There's some movement in the machine translation space as well. So far, I'd say that the impact is rather low, but 2024 might be a year of real impactful LLM implementations in language technology. That being said, I would like to thank you for your attention, and I think we can wrap up the session by saying that Nimdzi partners will have a copy of the presentation, will have a copy after the slide deck will be provided to you. If you're interested in knowing more about Nimdzi Insights, what we can do for you, what we have to offer, if you want to know what becoming a Nimdzi partner entails, feel free to send an email at info@nimdzi.com, and we'll be happy to follow up with you and figure it out. Thank you very much for your attention. I wish you a pleasant day, pleasant evening, and I will see you next time.